So as with anything, there's dozens of ways we could implement this. I'm going to reset this to 0 just for a moment. In the real game on Lumines on PSP, the preview of the upcoming quads there's like 3 of them, and they're like on the left hand side of the screen right here. And the bottommost one is the most distant, and the top one is the one you're getting next, and this one's you're getting after that, and this one after that. And they sort of slide in from nowhere, like it slides in the middle of the screen, but there's nothing that it comes from. It just like suddenly appears as if it was invisible below this line, and then suddenly slides and it's totally opaque above it. And the same thing here, the top one slides off the top of the screen and then fades in at the same exact time in the top slot here for when you're going to control it. So it sort of becomes translucent or transparent and too opaque here as it slides up the top here. So what I plan to do is have them slide in from the bottom and then just like slide along until they get to here. And then the one, when it is about to become the one you control, instead of sliding up the top, I'm going to have it sort of fade away and then fade in here. But I'm not going to use translucency. I'm going to use like a mask. Well, I'll show you what I mean when we get there, but we're going to use a tutorial that I saw online. I'll credit them when we get there, but for now let's just focus on sliding these things and creating the objects to actually show something there. So because they are quads, and they are quads, they're going to look exactly the same as the quad we have here, but they don't have the same behavior as the quad that the player controls. I'm not going to worry about creating actual blocks. I'm going to instead create a new actor that has the same blocks, but they're not going to be actual blocks. So I don't want them to be blocks because then they'll be affected by all the get all actors of class block, that we call in multiple places throughout the functions. So instead they're going to look exactly like quads, but they're not going to be quads. So I'm going to make a new C++ class. I'm just going to you can call this whatever makes more sense to you. I'm thinking about calling it PreviewQuad. You could call it upcoming quad, or whatever makes sense to you. I'm going to call it PreviewQuad. And it's going to represent the 3 quads that we see here that represent the upcoming quads. So PreviewQuad, go ahead and create that. And once that finally gets generated, we can make a child blueprint, PreviewQuad BP. And I'm going to go ahead and, let's see, I'll leave the default scene root, but I'll add 4 static meshes for top left, bottom left, top right, bottom right. I think to do this, we'll be incorporating the game mode when we spawn a new quad and decide what color it's going to be. When we spawn one in here, instead of, so we need a way to populate the first 4 total quads, right? Because we need the starting one here, and then 3 more for over here. And then once we have this initial setup, every time we spawn in a new one, it's going to be bringing it to here, and then the older ones, the older ones are going to become the front of the queue. So yeah, it's a queue system with the newest ones being pushed up here and the oldest ones being pushed out to the player's quad. So we can implement a queue. We can have like a totally separate queue manager, or we can do that just internally inside of like the game mode. I'll just do it in the game mode, I suppose. So we'll have an array called PreviewQuads. And it'll be of type PreviewQuad BP. We'll go to the event graph. So on begin play after the timer bar and the grid have been created. So for the preview quads, we're going to spawn 3 quads in to those slots, and then we'll spawn, I guess we'll spawn the player quad first. So let's make this an array. First, let's get rid of this. Turn this into an array by right-clicking. And it's only ever going to have 3 elements. Now to spawn in these quads, we want to sort of have a separate way of handling them, because they're not going to be actual quads of 4 block blueprints. These are going to be created based on the colors of the quad at index 0 in the preview quads. So colors array, every preview quad is going to have a colors array associated with it, and the colors array that we're going to spawn our player quads in from is going to be grabbing these, so like from element 0 of preview quads. I think this setup will work fine. We just have to be careful about when we are moving the array elements downward and like popping them off the front of the array or the back of the array, not the front of the array. We need to make sure that the locations don't mess up. So the primary concern I have is if the player spams new blocks really quickly, if the blocks don't have time to move to their new position before the next movement occurs, we want to make sure that it's like smooth and dynamic regardless of how quickly the player is dropping new blocks and spawning new ones in. So we just have to, design it properly so that even if the animations don't finish before the next time they have to move, we don't mess up the queue. So it shouldn't be that hard to do, but it's definitely going to take some careful design work. But for now, we'll just design our first implementation, and if it doesn't work, we'll figure out what we need to do to fix it. So for now, we're going to have 3 quads. We need to have the initial setup, and then this function needs to become what happens every single time a new block is spawned. But we need an initial setup too. That may be a separate function that just spawns 4 blocks in place. So in terms of the placements, I think a simple way to do this is to just have like locations for where each block is going to go. So I'll have a separate array of vectors to represent the positions for where every index of the preview quad array should be. So we'll have preview quad positions or locations. And it will be an array of vectors. Each element of this array represents the location of the preview quad with the same index in the preview quads array. So like at index 0 of here will be the location where the quad at index 0 should be. Like say it's this location right here, and then here's the location for quad 1, and here's quad 2, this is quad 0, and then the player's quad is not part of the array. So we'll make a new function that just is like initializing the 4 quads total. So we need to make 4 new quads. Really we're only making 1 quad, and the rest are preview quad, which is a separate entity entirely. And we'll have a method of transitioning from the preview quad index 0 to the real player quad. First, let's define what's actually in a preview quad actor. It has its 4 static meshes, which we can just make cubes. And we're going to have them be oriented appropriately, so this will be off by 50 maybe in every direction, so that they line up as we expected. This is bottom left, so it should be down here. Hopefully this is relatively self-explanatory. I want these to be lined up as if they're one of the player-controlled quads. But I need to check the scale on the blocks to make sure I'm doing this properly. So the blocks have a scale of 0.92, so I'll do the same thing here. I can select multiple of these with shift click and then set them all to the same scale. And now I just need to construct these based on the input array that they get, the colors array that they get. So the game mode is going to pass in. I guess I can do it like this actually. So we'll have colors array, an array of booleans to match the type that is made here on spawn new quad with the colors array for our decide colors. So decide colors will return the array that we're looking for here. So for each element of this preview quad, so I'll do a for loop from 0 to inclusive, so from 0 to 2, so 0, 1, 2, 3 times. We'll run decide colors for new quad. Now this is the initial setup. We won't do this, more than once, only at the very beginning of play. And then we're going to set the element at this index, or maybe even simpler, we can just make array, and we'll spawn actor from class, preview quad VP, and we need to set this to be exposed on spawn and instance editable, and then we can go to the game mode and compile. Spawn actor from class, preview quad BP, colors array, set that to the output of this function. Maybe I could just run it 3 times if I want to set array element index 0, or index whatever the current iteration of the loop is, and set it to the newly spawned preview quad BP. And as far as the transform for this new actor, the rotation and scale will be default values they'll just be, these values will be fine. And then the location is going to come from the preview, which I've misspelled here, preview quad locations array, same indexes, which we're going to have these be just default values that we set here in the editor. And to find these values, I'm just going to temporarily add just something to the scene here. I'm going to delete this in a minute, but I'm just using this to find a good location in the world. Actually, I'm going to use a block so I can see it better with the camera here. So if I click the pin here, then I can look at the camera while I move the block around. The Y value is not that important, but the X and Z values are what we care about here. Now keep in mind this is the center point of where the quad is going to spawn around it. But we can tweak this later, but for now I'm going to pick, let's just say, negative 400 in the X, 0 in the Y, and 1200, 800, and 400. Let's try that. So in the game mode, we'll do negative 400, and then I said 1200, 800, and 400. So I'll delete this block now and unpin the camera. It doesn't really matter whether it's unpinned or not, but now we're going to feed in these values. So get a copy or a reference, doesn't matter. I'm just going to say copy because we're not planning on changing it. Index, put the location there. So based on which index of the loop, the iteration of the loop it is, we'll get a different location corresponding to the proper element we're currently spawning. And now these should be spawned in with the proper settings. We need to make these actually do something, so go back to PreviewQuad, and we can basically do the same thing we did in block BP, set color by Boolean. Now we're not going to ever change the colors of these in the PreviewQuads. All we really need to copy from this is this here, this selection of nodes right here, which isn't really that hard, but we're going to copy it anyway. So when we're constructed, we want to set our materials for the different static meshes based on this. So just to remember what these are, let's check we need to actually go to spawn new quad and see which index of the Boolean array corresponds to which of the 4 quad blocks. So 0 is BL, 1 is TL, 2 is BR, and 3 is TR. So I'm going to just copy these real quick into here, just to have a reminder of which one's 0, 1, 2, and 3 without having to write it down, because I'm that lazy right now. So for index 0, whether it's 0 or 1, we'll be setting BL. And then 1 is TL, 2 is BR, already have that, and 3 is TR. So then index 0, we do it like this. If it's 1, if the Boolean at index 0 of this array is true, then we're going to do the top here, otherwise we do the bottom. So for block color 1, unmatched inst, block color 0, unmatched inst. Then I'm just going to set these real quick. Just do the same thing over and over. And then we just need to wire it up and repeat the branch and converge type of thing. So first of all, let's move this out a little bit. Now we need to branch and do this for each index. So if true, it's going to go up and do the first one. If false, down here. But then these need to actually converge again so we can do another branch for the next index of the Boolean array. So we could do a sequence here, but this is going to be a rare case when I just go left to right, since it might be easier to see the pattern that way. Oh, and again, these need to converge on a branch, otherwise they'll be all or nothing. Actually, now that I have this logic, I'm going to TL, BR, TR. Just to save a few seconds of copying that same pattern over and over, I'm going to copy this instead. That's 3, and here's the 4th one. BL, TL, BR, TR. And then just wire this up. And then change the indices of the gets here so that we get the right index of the colors array. So then now in the game mode we have to make sure we're spawning in 3 of these and that the colors get set properly based on the thing. So here, this should actually just work now. We should see them. And they're not going to do anything, but that seems to have at least worked, so that's good. And now we need to worry about transitioning them and getting the new one into the play area. So first I'm going to get rid of these debug traces, the vertical lines, because that's just getting annoying now. Let's go to the timer bar, scan column, and make sure we turn off the debug lines. So after we spawn in these 3, we don't need to change what we're doing for the spawning in of the players, because it can just be its own thing. But once we do need to do that once at the beginning, and then we need to do something different than we're currently doing for every subsequent player quad. So right now it's getting, colors array from the return result of decide colors for new quad. So let's go ahead and remove decide colors for new quad from spawn new quad, because we're going to be doing this once at the beginning of play, and then we're going to be instead feeding these in from index 0 of the PreviewQuads array. But the first one that spawns in is not going to inherit from PreviewQuads index 0. It's going to get its own set of new unique colors. We already have colors array here. But instead of a local variable, let's actually make an input here on spawn new quad. So I'll make an input Boolean array called colors. We'll delete colors array, and instead, well, we can keep colors array and just do this. Instead of having this come in like that, just do this. That way we can still leave this like that. It's a little bit neater than having to connect all the red lines from the purple pin here, from the purple node to all the input pins over here. So we'll leave it like that, and we'll decide what is going to choose the colors based on whether it's the first node or not, the first player quad or not. So delete this here, and just scoot everything over a little bit. And when we spawn in the first player quad here, after we spawn in the 3 of these, we'll do a onComplete here. We'll do spawn new quad. And it'll take the result of decide colors for new quad. Now I'll make a comment here saying spawn in the initial player quad. Spawn in the player's initial quad, which does not take its colors from an existing preview quad. So that emphasizes the fact that we're deciding the colors in a unique way for the first quad the player controls. And now we're going to make another function called make 0th preview quad into player quad. So that's going to take preview quads index 0, get a copy of index 0, and get colors array. And now we're going to spawn in a new player quad. And right now we're just going to spawn in a new one, but in the future this will create the illusion of this element becoming the player's quad, but for now it's just going to, I think it'll all become clear by the end, or before the end. By the time we get close to the end, you'll see what I'm doing here. But for now we're just going to spawn a new quad based on this element's colors array. And then we need to move all the quads up. So, but for now, I'm going to make descriptive function names like this that are going to be really short, and we'll wire them up in the proper order as we go. So we'll have a sort of master function for slide all preview quads up. So called when the player finishes or like places their quad, their current quad, and the new quad needs to spawn in. So once the player places their quad and the game is about to spawn in a new quad for them, instead of spawning in a new quad for them, it will call this function. Well, this is going to be another one of like the helper functions for the main function. So I'm going to make a function called pop preview quads q and push preview quad. I don't know if there's a limit to how long these function names can be. That's really pushing it, but this is the main function for handling all this transition logic for adding a new. So it's doing what it says. It pops the 0th element of the array and makes it into the player quad, and then adds a new quad at position 2. And so, you know, what was at position 1 is now 0, 2 is now 1, and a new one is added at array index 2, and the 0th one becomes the player 1, and then is gone. So, you know, they're shifted downwards, and the one at 0 becomes the player quad. So hopefully that makes sense. When I say pop and push, what I'm referring to, it's informal here, it's not exactly true, but I'm taking 0 and popping it off of the queue and pushing the new 2 into the queue. So, you know, 0 is coming off, a new 2 is coming in. What was once 2 is now 1. What was once 1 is now 0. And 0 is popped off. So first we're going to make the 0th preview quad into player quad. And that's going to handle popping the quad, popping index 0 off of the PreviewQuads array, pushing everything down, and then spawning in a new one will be, part of it. So we'll have make new PreviewQuad as the final piece of this puzzle here, where we first turn the 0th element into the player quad, move all the quads up, and then add a new one to the end. And then we'll return from this bigger function. So now obviously we need to make all these functions do what they say in their names, and then it should all just work. So my plan for transitioning from the index 0 preview block, preview quad, to the player quad is to use this really cool dissolve effect that's achievable in Unreal. I found this out I went to Google and typed in like UE4 enemy dissolve effect, and so there's this really cool blog post by Jeff LaMarche called Disintegrating Baddies Dissolve Effects in UE4. So he goes over this really cool dissolve effect that he made in Unreal, and I'm not going to go over how to do it because his tutorial here on Disintegrating Baddies is really thorough and explains it better than I probably would in a brief amount of time. So you can follow along with that if you want to, or I'm going to show you the finished product that I got by following along with his tutorial. So I followed along by making a new material, and this is the whole graph that creates the logic necessary for this dissolve effect. So you can, pause and go through this to copy everything if you want to. There's a divide here, so you just right click, type in divide, and then use that node and put 100 on the denominator there. So these are scalar parameters. I named them fringe size and dissolve amount. Fringe size, dissolve amount, fringe glow intensity, and the default values there. A separate color for the fringe, and then I use the same color as I'm using for my two block colors as the base. Make sure this is a masked material here, which this is something we're going to have to change in our base materials. If we incorporate this as part of our current materials, we'll have to add this logic into our other material, so I'll do that in a minute. But the goal is to have this material on the block like this, and then when it's about to become the player block, the block in the queue on the left hand side will do this and sort of dissolve gradually like that, and then at the same exact moment the player's block will fade into view like this. So it's like translocating, from the queue into the player's block rapidly like that, with just enough to give it a cool visual flair, while also hopefully being unobtrusive enough for the player to not have to focus on what's coming next in the queue, and just if they want to, they can kind of glance at it while they're playing their current block, so they, it's not too obtrusive. The goal is to make it look cool without being, without hampering gameplay. And I figured this would be, having it dissolve in place and appear in place would be better than having it fly from left to right into the center of the screen, because that can be distracting, I think. So that's the goal anyways, to do that. So this this texture that creates the the noise effect for where the thing begins to dissolve and where it begins to appear, I found that by just doing a Google search. I typed in noise map. I used the Google search tool on Google Images that lets you search for things that are labeled for reuse, so you don't have to worry about copyright issues. So I just picked the first noise result. It's called Perlin Noise 2D.png. It's on Wikimedia Commons. So that's what I'm using for the texture, which I used here in dissolve texture, Perlin Noise 2D. And that gives it a sort of interesting, dissolving effect. And then that fringe is what the edges here, that's the fringe. And you can choose how thick you want that to be with the fringe size parameter. So all this logic for the ifs and everything are explained in Jeff LaMarche's blog. Again, that's called Disintegrating Baddies. It's really cool if you want to check that out. and then you'll understand this better so that you can make changes to it and use it in your own projects. But at the end of the day, all this plugs into mostly the opacity mask and the emissive color, so we're not really using those in our base mesh currently for the like unmatched colors. We have emissive plugged in, but it's at 0 for the base color. So okay, we have two options here. We can have two separate colors, one that's used for the dissolve effect, and then you switch to a new material that will be used for the highlighting effects. I'm going to go ahead and try that, I think. We're just going to have a huge amount of textures and materials here, but I'm going to go ahead and use a separate one. I'm going to use the one that I have here in dissolve materials, so that way I won't have to change the current materials too much. But I'm going to go ahead and copy these parameters just so I can keep the colors exactly as they are right now when I do this. So now I'm going to have to move these down so they don't get in the way. Add these 3 parameters and just plug them in. And do the same for the other material, dissolve base 1, which is the separate base color. So the point of doing this right now is so that I can, once a block has finished fading in, so with this, the preview blocks, the PreviewQuads, are only ever going to use the dissolve base material, or the dissolve instances. And then the block BPs, when they spawn in, are going to have dissolve instance materials on them. And then once that material has finished its animation of becoming fully opaque, then we're going to switch its material to the old materials that we've been using, these ones, so that the highlight and match effects will still play out as they currently do. So if that doesn't make sense, just follow along and it should hopefully make sense by the end. When we set color, we're initially going to just set to the new materials that I've created, the dissolve base 1 and dissolve base 0, or instance 1 and 0. It needs to be the instance so we can change the parameters on it. So dissolve instance 1 and dissolve instance 0. Set that as the current material, and then we're going to do a timeline that changes the color over time until it's fully opaque, and then it's going to switch to the old colors that we've been using before. So after we set the material here, we'll do now we'll set it up at the end of the construction script. So compile that, or on begin play rather, so that we don't have to worry about construction things. On begin play for the blocks, we will run a custom event, or we can do the timer right here. We can just do a timer, a timeline that says, based on what color we are, we're going to set our target material. We're just going to change the color. There's no timeline that needs to occur here. It's just a timer. So we do need a timeline to change the scalar parameter, and then that'll update automatically. And then when the timeline completes, that's when we change our material back to one of the two types here. So let me just go back to this function real quick. I'm just going to copy this, go back to the event graph at begin play, we'll create a new timeline, add timeline, dissolve opacity, it's just going to be a float, and we'll say it takes, we want it to be relatively quick. Let's do like 0.8 seconds, and if that's too slow we can speed it up. But we don't want it to be so fast that it's just a flash. Oops, I don't need this one. Let's delete that. Call this opacity or something like that. Doesn't really matter. It's not really opacity. It's just the percent of how active the mask is. So we'll have two values here, just a linear from 0 to 0, and then 0 to 1, or sorry, 0.8 for the time, and 1 for the value. And then back to the event graph. We're going to play this from start. And on update, we need to update our parameter on our current material. So get our material and set scalar parameter value, and make sure we check the name of what the parameter is called. Dissolve amount, no space in the middle. So we need to set dissolve amount. Now we need to be careful that we're not thinking backwards here. So when this value is full, when it's 1, then it's completely invisible. So we want to start at 1 and actually go to 0 so that it's 0% dissolved when it's fully opaque. So we might want to do that backwards and have the timeline just be going from 1 to 0. So let's go ahead and do that. Change the timeline values so that at the end of the transition it's at 0, and at the beginning it's at 1. And on update we just set the scalar parameter to the current value here. I'm just going to change this from opacity to dissolve percentage so that it more accurately reflects what's going on. And now we'll move this over a little bit. This is fine. And then when it's finished, we're going to do this based on what our color is. Branch out and do one of these two things. But instead of the dissolve materials, we're going to go back to our block color 1 unmatched inst and block color 0 unmatched inst. Now let's kind of see if that works at all when we just play right now. And let's not play because there's an error. Somewhere in one of our materials it looks like. Oh no, it's in the player controller. Oh, here we go. When we spawn in a new quad, it has nothing to do with actual colors, it's our array of colors. When we're spawning in a new quad when we finish falling, this now has a new parameter that we weren't accounting for. That's because we need to change this to incorporate our new logic. So for now I'm just going to make array just as a band-aid that it will peel off in a few minutes. I'm just going to make an array of Boolean values and just have them all be like this, just so we can test it. And there's another place where we need to do the same thing. Now we won't need to spawn this new quad in, will we? Because in the game mode, we are on begin play in the game mode. We're spawning in a player quad right here. So we no longer need to do that in the player controller. Now let's see what happens if we try to play. Hopefully there's no more errors. Okay, so we just saw that the blocks spawn in with a dissolve effect. It's actually probably too slow. So I might speed that up to like start filling in them faster and then slow down towards the end. So we can do that by just adding a few things to the timeline on the block. This timeline we can sort of have it, be a bit of an exponential curve downwards like this, so that more quickly it becomes full and then slowly fills the rest in. Something kind of like that. That's almost too much, actually, too quick. You don't even see the effect anymore. So back to the block and change it a little bit. Maybe that's better, or maybe it's the same as original. I don't know, but I think it's fine. This is because we're not changing the material properly, I think, because now it's not highlighting properly. But the logic is still working to turn it into matches, but the colors aren't lighting up properly because the emissive value is not working, I think. Let's see, let's confirm when does the highlighting work and when does it not work. Seems to be a little bit random almost. So to diagnose this issue, if we go ahead and click play, and if we observe the issue again, we'll see seemingly randomly some of the tiles will be highlighted as we expect. Like, this is what we want, right? But sometimes they stay non-highlighted even though they do scale up and become matched. See, there's no gap between them, so they are scaled together, but they're not lit up. If we click one of the ones that are lit up and we go to the block mesh and look at the material instance on it, and if we double click on this, we can see that the parent of this dynamic instance is the unmatched inst. So that means it became the unmatched one and then transitioned to the lit up one due to the timelines we have. But now if you look at the ones that are not lit up and we go to the block mesh and we go to the double click on this, we see it's still dissolve inst 0. So somehow this one never became parented to the old materials that we have, not the dissolve mesh. It's still staying with the dissolve material for some reason. So somehow we need to ensure that every single block transitions to the one of these unmatched inst. Maybe somehow some of these aren't finishing. So let's do a print statement here and see if we can figure out what's going wrong with the blocks that don't change color. If they never get here, then obviously this will never print out. Let's just get a reference to self and then print the string like this, which will convert our self to a name. And this will run whenever any block that spawns finishes its dissolve transition and turns into one of these blocks. So I'm just noting to see we get 4 of these prints every time we spawn in a new quad, which is obviously what we expect to happen. And yet none of these ones became highlighted as we would have expected. And then those 2 did, so let's eject. Click on this one. This is block BP20 and this is block BP22. So if you look here, we do have 2020 and we have 22 here. So they're all printing, they're all finishing that initial timeline and printing out there at the end. So from this printout, there's nothing special about these 2 blocks. So again, just like the previous time where we had the one material wasn't properly changing to the metallic material, and one of them was, this is another instance where I don't understand why the materials are misbehaving. The only thing I can think of is that I'm misunderstanding something about how dynamic material instances operate. I don't know how to solve that particular issue the right way, but I do know a way that we can work around it by adding a third mesh here, another static mesh at the same location, same scale and everything. And that is what will accept the dissolve material. And then we'll keep this one as our normal material. And we'll just, you know, hide one of them and then make the other one appear at the right time to preserve the current visual effects that we want. So to do that, we're going to have the default mesh initially be invisible. We're going to add another static mesh, and I'm going to call this the dissolve mesh. And it's going to be a cube again. Same scale as this one, so 0.92. Now we're going to, on construction time, we're going to just have a separate material here. So we'll have dissolve matte dynamic, and this will be of type dynamic material instance. And we'll keep this, we'll just duplicate this logic. Well, actually, duplicate this entire thing here. And I'll do a sequence just because I like having a sequence to keep everything on one screen at the same time. We'll revert this to the block because that's how it was before. So this will be for the block color 1 unmatched inst and block color 0 unmatched inst. And then set these to my matte inst. And then when we do the same thing for the dissolve mesh, we can leave everything the same and just change the names. So this will be dissolve base, or dissolve inst 1 and dissolve inst 0. And then we're going to set dissolve matte dynamic here. And then apply that not to the block mesh, but to the dissolve mesh. In the event graph, instead of doing anything here like this, we're just going to, we should be able to get rid of that print statement too. We're just going to set the visibility on the dissolve mesh to false and set the visibility on the box mesh to true, and that will hopefully resolve the issue. You know, it's a bit inelegant because we're wasting performance by having two cubes sitting inside each other, but should be fine. Let's also make sure we turn off overlap events with this new material here. This new turn off all collision for this new mesh. Now again, the normal mesh is going to be initially invisible and the dissolve mesh is initially visible, and then they'll switch when the animation has finished playing out. And we want to make sure when we do this animation we're changing the parameter on the dissolve material instead of the my matte parameter variable. And now let's just see what happens because I'm not too sure. Yep, okay. Lots of problems. Let's see what started this issue. We're trying to read property dissolve matte dynamic, access none, trying to read this. So when the block is constructed, we set color by Boolean. We set dissolve matte dynamic in this sequence. Oh, here we go. This is being bypassed by the return node that's right here, and we don't want that to happen. So let's clear the log, and hopefully that doesn't happen again. Okay. Now we want to verify that the highlighting still works. Hopefully they'll all be lit up like this when we do matches. And this will probably have a performance impact if we're actually, you know, getting bottlenecked in performance already. Then having a separate mesh on each block is going to be an issue. But since only one is being visible at any one time, I think it'll be fine. And there's no visible difference between, you know, these blocks right now and a moment before when they are a different material. It seems to be pretty smooth. After it fully fades in, then it just looks the same and lights up properly and turns into a highlighted block properly. So that is good. Now on to actually updating these and moving this one over and stuff like that so that it actually works properly. There is a difference, if you can see, in the color between like the orange here and here. If it's come through in the video, I'm not sure, but you can tell a subtle difference in color. It could be due to the grid around it, or it could be due to the placement relative to the point light we have. So we have the point light in space on the right hand side, I think. So yeah, it's closer to this side, so it might be not touching these ones because it could be dropping off the further it gets from the grid, or something else. It's not the end of the world, and if that bugs me at the end, I can figure out why. Let's move on to sliding the blocks from place to place.